Hey guys, it's Mr. Gron. Here's the 3.4 day 2 lesson. It's really just one example and then more practice time at this. So get through the example, try to do your best with it, take a look at the homework, try to help each other out, come with questions on Tuesday, and we'll wrap this stuff up and move on to 3.5 on Wednesday. So take a minute, pause the video, read this on your own. You might have to zoom in, and we'll take a look. I'll get it a little closer. So maybe pause now. Okay. So the first thing that I did when I approached this, and it's not a bad idea with word problems just in general, is to organize your information. So I took all of the things and I put them into a table over here. Right, so I've got for almonds and walnuts, the bags per case, the cost per case, and the profit per case. That's all the important information that I'm going to need with this. So the first part of the problem then, part A, was come up with the system of inequalities that's going to satisfy this. So I know that I can have no more than 300 bags of both of these combined. So, oops. 20x. So that's the inequality that is going to satisfy the first part for the bags. The second constraint was the cost. I had a cost that could be no more than $400. And that first part doesn't involve the profit. The profit is going to be what we optimize. So that's going to be our objective function is what that's used for. To really be technical, we should also define that both x and y have to be greater than or equal to 0. We're not going to have negative almonds or negative walnuts. Okay, second part was graphing this. This is kind of set up to graph using the intercepts, but we really want to be careful here because we're going to have some decimals. Now, x-intercepts, if I cover up the y, 20x less than or equal to 300, excuse me, that means that x has to be less than or equal to 15. 15 is our x-intercept. For the y's, if I divide both sides by 24, y has to be less than or equal to 12.5. Now, we're not going to order 12.5 cases, so that's an important thing, but we still want to use the intercept as accurately as we can, even though it's a decimal. This one gets a little bit hairier. 30x less than or equal to 400. If I divide both sides by 30, I get 13.3 repeating. This one, the y-intercept, gets even uglier, because if I now divide both sides by 26, y is less than or equal to 15.4, or it's actually like 15.38 something, but we're going to use 15.4 because I can't graph any more accurately than that anyway. All right, so now graphing. My intercepts, x-intercept for the top one is 15, y-intercept is 12.5, so right about there. I really want to be as accurate as I can with this. See, there I wasn't being very accurate. I didn't have the straight edge on there, right? Okay. And then for my other one, 13.3, I really got to think. There's 13, so a third of the way is probably right about there. And then here's 15, so 0.4 is not quite a half, so right about there. Now, if I do this accurately enough, which is actually a little tricky when you're using an expo marker on a whiteboard, if I do this accurately enough, I can see that the intercept is right there, right in the middle, so it's at 9.5. Now, for some of these, if you don't graph it very accurately, you might have to do a little bit of guesswork to see where it is. Maybe test some points that are really close to it. Now, my important points here are going to be 9, 5, where the lines intersect. My shaded area is going to be this area right here. This one, 0, 12.5, that's one of our vertices. This one over here, 13.3 repeating 0. And then 0, 0 is also a vertice, but that's not going to be realistically going to be the maximum, right? Okay, objective function. Now, looking back at our profit, we had a profit of $15 for one and a profit of $17 for the other. So that means our objective function is going to be P equals $15 per bag of almonds and $17 per bag of walnuts. I want to test out my vertices. One vertice was 0, 12.5. Now, I can't buy 12.5 cases. I can buy 12, though, so I'm going to go with the closest one without going over. So 0, 12. That's going to be 15 times 0 plus 17 times 12, which is $204 in profit. 9, 5, 15 times 9, and 17 times 5 is $220. And again, 13.3 repeat, and I can't buy a third of a case, so I'm going to go the closest, which would be 13. So 15 times 13 and 17 times 0. And that is $195. Now, I'm not going to do 0, 0 because I think we can probably see that 0 times 15 plus 0 times 17 is $0, which is significantly less than all of these. That would be our minimum value. Our maximum was the middle one here at 9, 5, so that is our solution.